Welcome back to next session. So it is virtual instrumentation software such as LabVIEW and how LabVIEW is used in signal conditioning or in acquiring the data. So apart from LabVIEW, there are many softwares available. Let me introduce a few of them here. So, virtual instrumentation software is normally used for modeling, analysis, design, data acquisition, and control, or input activities within the field of mechatronics or automation. Computer software tools and environments are available for effectively carrying out both at the learning level and at the professional application level. So, one such software is MATLAB. Is an interactive computer environment with a high-level language and the tools for specific and technical computation, modeling and simulation, design and control of dynamic systems. Simulink is a graphical environment for modeling, simulation and analysis of dynamic systems and available as an extension to MATLAB. So Simulink is a part of MATLAB only, but it is a graphical environment, whereas MATLAB is a high level language. You have to code it. So LabVIEW is also a graphical programming language and a program development environment for data acquisition, processing, display, and instrument control. So the Simulink provides a graphical environment for modeling, simulating, and analyzing linear and nonlinear dynamic systems. First, a suitable block diagram model of the system to be developed on the computer screen and stored. The Simulink environment provides almost any block that is used in a typical block diagram. So these include transfer functions, integrators, gains, summing junctions, inputs, source blocks, and outputs. So graph block and scope blocks. Such a block may be selected and inserted into the workspace as many times as needed by clicking and dragging using the mouse. So it is very simple and simple environment to use. These blocks may be connected as required using directed lines. A block may be opened by clicking on it, and the parameter values and the text may be inserted as modified as needed. Once the simulation block diagram is generated in this manner, it may be run and the response may be observed through an output block, graph block, or scope block. There are two types of elements in a Simulink. One is blocks and lines. Blocks are used to generate or input, modify, combine output, and display signals. Lines are used to transfer signals from one block to another. So these are the two elements in Simulink. So starting Simulink, first enter the MATLAB environment. You will see the MATLAB command prompt. So this is the double arrow. To start Simulink, enter the command Simulink. Alternatively, you may click on the Simulink button at the top of the MATLAB command window. So basic elements, blocks, the subfolders below the Simulink folder show the general classes of blocks available to use. So continuous, linear, continuous time system elements, integrators, transfer functions, state space models, etc. A signal can be either a scalar signal, so see a single signal, or a vector signal, several signals in parallel. The lines used to transmit scalar signals and vector signals are identical. Wha- Whether it is a scalar or vector is determined by the blocks connected by the line. So this is one example state space diagram, and you can see the input torque, input force, and that can be displayed using these scopes. So scope, how much you are giving as input torque, that can be displayed here also, and you have force display here, and this is the integrate. This is the junction from where you can send the both signals to the state space unit. So here all mathematical modeling is performed, and output force and output angular velocity from this state space equations are displayed here in the respective scopes. So the input torque, input force, output force, and output angular velocity, the graphs directly can be obtained in Simulink, and those can be recorded or those can be downloaded. And if you see MATLAB, so here MATLAB interactive computer environment, it is very useful in computational activities in mechatronics and automation. Computations involving scalars, vectors, and matrices can be carried out, and the results can be graphically displayed and printed. MATLAB toolboxes are available for performing specific tasks in a particular area of study, such as control systems, fuzzy logic, neural network, data acquisition, image processing, signal processing, system identification, optimization, model predictive control, robust control, and statistics. Mathematical computations can be done by using the MATLAB command window. Simply type in the computations against MATLAB prompt. So this is the MATLAB prompt. So any example of simple computation using MATLAB is given here. So this is the command prompt, and x equal to 2, y equal to minus 3. So z is the output. So x to the power 2 minus x into y plus 4. So that is equal to z I am getting as minus 14. So this can be performed as you have to type everything. So it is not a graphical environment. So these are the MATLAB operations. So here plus addition. So these are the arithmetic operations. So this is upper arrow. It is the representation of power, and you have mathematical functions. The log functions, absolute value. So arc, cosine, arc. Hyperbolic cosine. So here arc sine, arc tan, cos, cosine. So hyperbolic cosine, exponential functions, log, natural logarithm, and log base 10. So real part of complex number. So you have all the functions, and then you have related operations, lesser than or equal to, and similar functions. You can have basic logical functions, and, are, and not. So there are many commands available. So coming to the LabVIEW, LabVIEW is in short, it is called as LabVIEW. It is actually laboratory virtual engineering workbench, is a product of National Instruments. So any details you require about LabVIEW, you can always refer the LabVIEW, that is National Instruments website. It is a software development environment for data acquisition, instrument control, image acquisition, motion control, and presentation. LabVIEW is a compiled graphical environment which allows the user to create programs graphically through wide kinds, similar to creating a flowchart. So working with LabVIEW as a software centered system, LabVIEW resides in a desktop computer, LabVIEW laptop, or PXI as an application where it acts as a set of virtual instruments. So here the virtual instruments, whatever real instrument we have, so the replica will be available in the form of virtual instruments, providing the functionality of traditional hardware instruments such as oscilloscopes. Comparing to physical instruments with fixed functions, LabVIEW VIs are flexible and can easily be reconfigured to different applications. It is able to interface with various hardware devices such as GPIB, it is general purpose interface bus, data acquisition modules, distributed IOs, image acquisition, and motion control, making it a modular solution. So peripheral component interconnect, so our PCI extension, that is PXI. So you can see here LabVIEW is in a computer or laptop within a PXI also it is possible. And here you can see GPIB board, that is general purpose interface bus, modular instrumentation, data acquisition, distributed IO, image acquisition, motion control, everything is happening here. And then you have physical system, that is composed of sensors and other systems. So this is about LabVIEW. And there are for the best information you can get from a National Instruments website. Apart from that, you can refer our regular books. So there ends the LabVIEW. We have one more topic to cover in this unit. We will discuss that in next session. We will stop here, students. Thank you.